We're going to continue on with our trig unit here by talking about how we can evaluate trig functions. So we're going to relate what we did last time with reference angles to how we can use those to help us evaluate some trig functions for us. So first we're going to talk about how we can evaluate trig values of special angles. So these are angles of special triangles. So you memorize these as a 30-degree angle, the 45-degree angle, the 60-degree angle. So we'll be working with those today. Now, for any angle that's not in quadrant 1, the trig value for the angle will be related to the reference angle in that it will have the same value, but it could possibly have a different sign. So it might be positive, it might be negative. Now, the letter in the quadrant that you see there in your notes indicates which function is going to be positive there. And the easiest way, I think, to remember what is positive in each quadrant is to use this. All students take calculus, where the beginning of each letter corresponds to what is positive in each quadrant. So looking at it this way, this looks, I think, a little bit more confusing, like there's a lot of information here. But if you look at it by looking at each quadrant, in quadrant 1, you can see sine, cosine, and tangent are all positive. In quadrant 2, only sine is positive, so S. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Now, in terms of the reciprocal functions will have the same sign as sine, cosine, and tangent within that quadrant. So for example, if you're in quadrant 3, you know that both tangent and cotangent are positive, and sine, cosine, secant, cosecant are all negative. Now, just as a note, if the angle you are working with is not in the first revolution, you can find the coterminal angle that's in the first revolution in order to simplify the problem. So that's how we can use coterminal angles to help us out here. So let's take a look at these examples. So two things that we want to have in front of us. So first, because we're working with the special angles, we want to have that chart in front of us, the one that we all have memorized or will have memorized by the end of all this. And we also want to have that little diagram with what is positive in each quadrant. So let's start with sine of 5 pi over 6. So let's draw that out. So 5 pi over 6 is going to be in the second quadrant, right? It's almost pi. It's 5/6 of pi. And remember, pi is half of a rotation. So 5 pi over 6 will take us into quadrant 2. So that tells us information about whether that answer is going to be positive or negative. But now we also need to know the reference angle. So the reference angle, that's this angle right here, that's going to be pi over 6. So now we know we want to look in our chart for sine of pi over 6, and then we take a look at our diagram here. All students take calculus. In quadrant 2, S stands for sine, so sine is positive in quadrant 2. So our answer for sine of pi over 6 is going to be just 1/2. So sine of 5 pi over 6, rather than trying to find what that answer is, we can use the reference angle, sine of pi over 6. And because it's in quadrant 2, we know it's also going to be positive. So this answer is 1/2. Now, if we had something that was in a different quadrant that was negative, then we would just attach a negative onto that. Okay, the next one, cosine of negative 8 pi over 3. So let's draw this out. Negative 8 pi over 3 means we are rotating clockwise because it's a negative angle measure, and that's going to be more than 2 pi, right? So it's 2 pi and then another 2 pi over 3, so another 2/3 of pi. So this is what it looks like, right? The rotation, one full rotation, plus another 2/3 of pi, going clockwise. So that takes us into quadrant 3. So in quadrant 3, all students take, so t, only tangent is positive in quadrant 3. So cosine is going to be negative. So this answer that we're going to have is going to be a negative answer. Now look for the reference angle. The reference angle is going to be this angle right here. That's going to be pi over 3. And so now we look at our chart. Cosine of pi over 3 is equal to 1/2. But because we're in quadrant 3, cosine we know has to be negative. So we tack on a negative here. So this is equal to negative 1/2. Okay, the last one, secant of 15 pi over 4. Okay, so 15 pi over 4, let's draw that out. So 15 pi over 4 is definitely over 2 pi. So it's actually almost, 4 pi. So this is what it will look like, right? A full rotation plus almost another full rotation, but not quite. That's 15 pi over 4. So we are in quadrant 4. In quadrant 4, we know, all students take calculus, C, cosine is the only thing that's positive, cosine and its reciprocal. Now we are working with secant, which is the reciprocal of cosine. All right, and now the reference angle, this angle right here, that is pi over 4. And so secant of 15 pi over 4 is the same as secant of pi over 4. And now because we're working with the reciprocal, you want to look for cosine of pi over 4. Cosine of pi over 4 is root 2 over 2. So secant of pi over 4 is just this reciprocal, so 2 over root 2. We know it's positive because in the fourth quadrant, cosine and secant are both positive. So 2 over root 2, rationalize that denominator, and we get the square root of 2. Now, what about trig values of other angles that aren't special angles? Well, we can actually find the trig value of any angle if we know a point that's on that terminal side. So let theta be an angle in standard position, with x comma y being a point on the terminal side of theta, and r is equal to the square root of x squared plus y squared. Now this picture right here actually is just showing us the description that we just described here. Now, it doesn't have to be in quadrant 2. It could be in any of the quadrants. Now notice that really what we're doing is we're working with a right triangle. So x and y are coordinates of the point that's on the terminal side. It doesn't matter where it is on the terminal side. We actually are creating for ourselves a little right triangle. And so for us to evaluate the values, we can use r as being the hypotenuse, which is why we have this square root of x squared plus y squared. That's how we would find the distance that r is. And then your x and y values are simply going to be the other sides, the adjacent and the opposite side. So if we're trying to find sine of theta, that's just equal to the opposite side over the hypotenuse, so y over r. Cosine is equal to the adjacent side over the hypotenuse, so that will be x over r. And then tangent is going to be equal to opposite over adjacent, so that's y over x. And then pretty easily we know what the reciprocals are. And just simply take the reciprocals of each of those, r over y, r over x, and x over y. Now when we are evaluating trig values of any angle, when we are using the coordinates of that point, x comma y, that will actually already take into account whether the value is positive or negative, because x and y will be positive or negative depending on which quadrant you're in. We'll see this in a moment in the examples. So here we go. Find the values of the 6 trig functions of an angle whose terminal side contains the point 8, negative 15. Here's a picture, if it helps. Here's 8, negative 15, so that's the terminal side. So x is 8, y is negative 15, and then r is the square root of 8 squared plus negative 15 squared, so that's going to come out to be 17. Now we can find the values of the 6 trig functions because we have x, y, and r. So sine is going to be y over r, so negative 15 over 17. Cosine is x over r, so that's 8 over 17. And then tangent is y over x, so negative 15 over 8. And then cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So that would be negative 17 over 15, 17 over 8, and then negative 8 over 15. Now you'll notice as we look at this, and I had said the positive and negative signs are accounted for because of your x and y values being either positive or negative depending on which quadrant it's in. So if you take a look at the picture that we have, notice we're in quadrant 4. Remember, in quadrant 4, all students take calculus, only cosine is going to be positive. Now if you look at the values that we found here, cosine is in fact positive, and its reciprocal is also positive. If you look at sine and tangent, they're both negative, which is exactly what we're expecting, and their reciprocals are also negative. So again, with these types of examples, where you're not using a reference angle, there's no need to account for the positive or negative. The only time you do have to account for it is if you're using a reference angle, because you're using an angle for reference, so it's not going to give you the exact value, but because you're referencing it, it helps us get the value, but then you have to deal with the positive or negative sign. One more example. Find the values of the 6 trig functions of an angle whose terminal side contains the point negative 3, 4. Okay, so we'll do the same thing. We draw this out, negative 3, 4. That's going to be in quadrant 2. And we have x, we have y. We still need to find our value of r, which is the square root of x squared plus y squared. So that's going to be equal to 5. Now again, if you recognize these Pythagorean triples, you can feel free to say that r is equal to 5 because it's a Pythagorean triple without having to do out square root of x squared plus y squared. Okay, so now let's go ahead and use those values. So sine of theta is equal to y over r, so 4 over 5. Cosine theta is equal to x over r, so negative 3 over 5. And tangent theta is equal to y over x, so that's negative 4/3. And then the reciprocals are going to be 5 over 4, negative 5 over 3, and negative 3 over 4. And again, just as a good quick double check, you're looking at the point that's on the terminal side, and that terminal side is in quadrant 2. In quadrant 2, all students, so S, so only sine is positive there. So if you look at what we have here, sine is positive, cosine and tangent are negative, and then the reciprocals are the same sign as sine, cosine, and tangent.